Good morning friends, welcome once again to the CEC-UGC live lecture. Dear friends, in this session today we are going to discuss on OR using computers. As you know that since very long we are carrying series on operation research, and regarding this series I would like to tell you all we are finally on the verge of ending up this series. We may be conducting few more lectures within this month on OR, but today we are specifically going to talk on how computers applications can be used in solving problems related to operation research. And for this we have again with us in our studios Dr. Subhash Kakkad. As I always say that Dr. Kakkad is an eminent academician, and with the help of workshops, seminars, he tries to distribute his knowledge for all what he thinks that the knowledge should be distributed from time to time to the students. So taking advantage from his experience, let's understand how operation research problems could be solved with the help of the computers application. So first of all, I would like to welcome our guest Dr. Subhash Kakkad. Dr. Kakkad, welcome to the EduSet lecture.
Thank you, Gitika.
And I hope that this session is going to be very interesting because we have discussed on operation research very much, but how with the help of computers operation research's problems could be solved would be very interesting. So
thank you, Gitika. Welcome viewers. Today's lecture is part of the series of our lectures on operations research. So far we have discussed topics using manual methods for finding the solution to our problems. I will just mention what all topics so far we have covered. Starting with applications of operations research, when we discussed a list of applications which can be used and find out a solution to our problems using OR techniques. Like we started with listing the applications, then we had transportation model. It is a model which is used in the transport industry, but this concept is also used in number of other applications. Then we studied assignment problem, and then we studied traveling salesperson's problem. Game theory, Markov chains, network analysis in the form of PERT and CPM. Linear programming, simplex method, big M method, goal programming, and even integer programming we discussed. Dynamic programming. In all these applications we have used only manual methods for finding the solution to our problems. We had only algorithms to solve the problem manually. Manually we know that we have some limitations. We can solve only small problems with small number of constraints, limited objectives, and then making use of our algorithm we used to find the solution to our problem. But in life problems where the problem's magnitude is very large and we face some difficulty in solving those problems manually, so we should need computers to solve the problems which are bigger in nature. And now today we will discuss how to use computers in solving OR problems. I will just here mention the definition of OR, a very simple definition of OR using mathematical principles to solve our problems. Our problem is there in the statement form. We list down the highlights of the problem. Then we make use of mathematical equations so that we are able to express the problem in mathematical terms. maybe in the form of constraints. We list the constraints which are applicable to the problem to which we require the solution. Then we list the objective function. It may be one function or more than one functions in the form of goals, priorities, etc. Again in the form of a mathematical equation. Then using mathematical principles, mathematical theory, and we find the solution to the problem. The same procedure is used in computers in the form of software. We will just see how the computer and software can be utilized to find the solution to our problems. Basically, a number of software are available which can be used in finding a solution to our problems with respect to operations research. Lingo is one of them, Tora another software, even MS Excel is used to solve the operation research problems, and many other software are available. So, we can make use of any of these software to find a solution to our problem. Of course, some of the software are useful for a specific use and some of the software are used for some other specific use. The moment we get experience with these software, we come to know that this particular software is easy to operate and this particular software is useful for particular this topic. So, today we will discuss some of these software, we will pick up some of the problems and then finally try to find the solution to that problem using computers. Let us have a problem, and the problem is a small factory produces two types of toys, cars and dolls. In the manufacturing process, two machines are used, the molder and the assembler. A doll needs 2 hours on the molder and 1 hour on the assembler. A car needs 1 hour on the molder and 1 hour on the assembler. The molder can be operated for 16 hours a day and the assembler for 9 hours a day. Each doll gives a profit of rupees 16 and each car gives a profit of rupees 14. The profit needs to be maximized. This statement is given to us. We have to pick up the important information from this statement. I will now list down the important information. There is a toy manufacturing company, this is the first statement, and this company is in the business of manufacturing two types of toys only. One is car and other is doll. And there are two manufacturing processes which are used to manufacture these two kinds of toys. One machine is called molder, the other is assembler. Then the capacities of the molder and assembler are given and the time required for manufacturing toy like doll or car is also mentioned. The time required on a doll, 2 hours on the molder and 1 hour on the assembler. This is the key information. And whereas the car needs 1 hour on the molder and 1 hour on the assembler. This is also key information. And the capacity of molder and assembler is also given. The molder has a capacity of 16 hours only in a day and the assembler has a capacity of 9 hours for operation in a day. This again information is over. Now, there is a information on the profit. If we manufacture doll, each doll gives a profit of 16 rupees and similarly each car gives a profit of 14 rupees. And these are the key informations, we have to keep it in mind while we move further. The further action is to make the mathematical equations to represent our constraints and our objective function. Let us do that. Formulating the problem. Maximize Z is equal to 16D plus 14C, where D denotes the number of dolls produced and C denotes the number of cars produced. As we have seen in the statement, 16 rupees a doll is the profit, 14 rupees a car is the profit, and then total is 16D plus 14C, which we have given the name as Z, and we have to maximize Z, maximize this function for 16D plus 14C. And now we will make the constraints, and these constraints are now, first constraint 2D plus C is less than or equal to 16, because each doll requires 2 hours and each car requires 1 hour on the molder, and molder capacity is 16 hours. On the assembler, each doll requires 1 hour, each car requires 1 hour, and the total capacity is 9 hours. So, D plus C is less than or equal to 9, and C and D both are non-negative. So, they cannot have negative values. So, the constraint is mentioned, C is greater than or equal to 0, D is again greater than or equal to 0. This completes the formulation of the problem. Now, we will make use of software to solve the problem. Our aim is to maximize the profit. So, we will start with Lingo. The moment we open Lingo, we get a picture on the screen as shown in the slide. Lingo is there written on the screen. We will move further, and Lingo, the word Lingo will get vanished, and we will have the spreadsheet. And this is a spreadsheet where we will enter our problem. On the top, certain things are there. We can get specific operations done on clicking those buttons. And this spreadsheet, we will enter our problem. What do I mean by entering the problem on this spreadsheet? Whatever constraints and the objective function we have listed so far under the formulating of the problem, the same equations will be written here on this spreadsheet. Of course, D we have used for number of dolls, C we have used for number of cars. This can be replaced by like x1, x2, x or y, or even we can keep D and C as such. So, let us make the equations on the spreadsheet. So, we have made the equations on the spreadsheet. Just look at this slide. Maximize 16D plus 14C is the first equation which shows the objective function. The second is 2D plus C less than or equal to 16, which is the first constraint, and D plus C is less than or equal to 9, which is the second constraint. This problem consists of one objective function and two constraints. The points to be noted here in this particular software are, when we have to multiply two things, we have to put asterisk sign as shown in the equation. If we do not put the asterisk sign, it will not multiply, it will show an error. That is why we have done in the objective function 16 asterisk D plus 14 asterisk C. And similarly, first constraint 2 asterisk D plus C is less than or equal to 16, and D plus C does not require any asterisk. So, we have not put any asterisk. The second point to be noted in making the equations, at the end of the equation, we have to end the equation by writing semicolon. If we do not put semicolon, the software will not accept this as an equation. So, there are two things which are to be kept in mind. The sign of multiplication we have to put always asterisk, and at the end of the equation we have to put semicolon. Once this has been done, means formulation of the problem has been recorded into the spreadsheet. Now we are waiting for the answer. To get the answer, there is a target button. As I have moved the cursor on the bull's eye, and we have to hit the bull's eye and then we have to enter. Keep the cursor here and then hit the end. The moment we enter, we will get the results, we will get the solution to the problem. The moment we hit, we get this kind of information on the screen. Let us try to read this information on the screen. First, on the left hand side, on the top, global optimal solution found is written. This shows that with these constraints, we are able to find out the objective function, and value of the objective function is written in the second line with objective value, and objective value is nothing but 140. 140 is the answer, which is a maximization of the profit, and then total solver iterations are given at the bottom. Now, how to know the number of dolls and how to know the number of cars, but these are given in the information written at the bottom. Variable, under the variable we have chosen two variables, one is D, other is C. Against D 7 is written, against C 2 is written. It means number of dolls to be produced is 7, number of cars to be produced is 2, to give a maximum profit of 140, and this has got through using software lingo. Again, if we change some of the information in the basic problem, means we have a different now formulation, then our result will be different. Now, look at the problem spreadsheet where maximize 16D plus 28 C is written. So, the profit from doll is 16, profit from car is 28. We have changed the information now just to show it to our viewers the second problem and how to find the solution. Okay. Of course, other things, other constraints are same, only the profit is changed on the cars. Cars profit is now 28 rupees per car. Of course, we are having the same constraints, 2D plus C less than equal to 16, D plus C less than equal to 9. Again, I will repeat the same thing, asterisk is to be entered for multiplication sign, and at the end of the equation we have to enter semicolon. This is what we have done after hitting the bull's eye, means target value. The value of the objective function is, which is given as objective value, now it is 252, instead of 140, now it is 252, and the number of dolls and number of cars are also mentioned. D is now in this case 0, C is 9. So, this solution is do not produce any doll, only produce cars and 9 in number per day, and you will get the maximum profit of 252 rupees. So, this is another problem and the solution is sought from the software lingo. Now, what is written here in the rows at the bottom? Row is given, slack or surplus is given, and dual price is given, even against value reduced cost is given. What is the meaning of these two informations which are written? So, I will explain. This is regarding sensitive analysis. Reduced cost means the reduced cost for any variable that is included in the optimal solution is always 0. The reduced cost shows how much the value of the objective function would decrease for maximum problem or for a minimum problem if 1 unit of that variable were to be included in the solution. So, this is the variation in the objective function if there is a change of 1 unit. And now, next is slack or surplus. What do I mean by slack or surplus? The slack or surplus column in the solution report shows how tight the constraint is. If a constraint is completely satisfied as an equality, then slack oblique surplus will be 0. If slack oblique surplus is positive, then this tells us how many more units of the variable could be added to the optimal solution before the constraint becomes an equality. If slack oblique surplus is negative, then the constraint has been violated. So, constraint has not been fulfilled, it has been violated when we get a negative sign, and this is the meaning of slack or surplus. And now, dual price. What is the meaning of dual price column? The dual price column describes the amount to which the value of the objective function would improve if the constraining value is increased by 1 unit. So, this gives us a sensitive analysis regarding the solution of the problem. What is the effect of changing the variables or the constraints by 1 unit and how the result is moving? This is given by sensitive analysis. Now, we will discuss one more problem using software, and this problem is now of assignment, and we call it assignment problem. Let us read the problem. Students of Miranda House College are organizing inter-college poster competition. Following jobs are to be assigned to 5 members of the poster competition committee. Each member of the team can do all the 5 jobs, but taking different times in hours. Give the optimal job assignment schedule to minimize the total number of hours. Give also the total time for completing the entire job. So, there is a poster competition committee, and this committee is organizing a poster competition in a college. Members of this committee, and there is a list of jobs to be done to organize this competition. Each member can do all such listed jobs, but the problem is each member takes a different time on a different job, and our aim is to assign a specific job to each member so that number of hours used must be minimum. It means we want that in minimum number of hours we are able to organize the competition. Now, we will see the table. Look at the table. On one side we have listed jobs and number of hours taken by each member of the committee. First column gives the list of students who are the part of that committee, who are the members of that committee, and second column is regarding the job sending invitations. Third column is preparing brochure. Fourth is inviting judges. Fifth is purchasing prizes. Last one is preparing certificates. Now, if we see the names of the students, these are written in first column. The first student takes 10 hours in sending invitations. The second student takes 9 hours in sending invitations, and similarly other students and their timings are mentioned. Second column also gives the timings, and these times are taken by different students in completing the second job, preparing brochures. Inviting judges, time required by each student is mentioned 3, 8, 6, 8, 9, etc. hours. And similarly, this table is complete, giving the number of hours each student will take in completing a specific job. Now, our problem is we have to assign these jobs one to each student so that the total time taken is the minimum. In our manual method, the first point to be done is formulate the problem. Let us now formulate the problem. Formulation of the problem, first we will write objective function in a mathematical form. Objective function is written like this: minimize 10x11 plus 3x12 plus 3x13 plus 2x14. How these are written? Just see the first row where the timings are written 10, 3, 3, 2, 8. And each job timings are like 10, 3, 3, 2, 8. And our variable is now for first cell x11, second x12, x13, x14 and x15. We will multiply these timings with the variable like 10x11, 3x12, 3x13, 2x14 and at the end 8x15. And this will complete first row, and similarly we have to complete all other rows. And if we see the next row we will write 9x21, 7x22, 8x23, 2x24 and 7x25. Similarly, the third row 7x31, 5x32, 6x33, 2x34 plus 4x35. Fourth row 5x41, 3x41, 5x42, 8x43, 2x44, 4x44. And now we are left with the last row. Last row will be like this: 9x51, 10x52, 9x53, 6x54 and at the last 10x55. This completes our objective function and we have to minimize it because we want that number of hours should be minimum. Now, we are to write constraints like x11, x12 plus x13 plus x14 plus x15. We will sum all these variables, and we know that in this first row only one job can be assigned to the first student. One will have some value, others will have 0, and the assigned job will have 1. So, that is why the first constraint is x11 plus x12 plus x13 plus x14 plus x15 equal to 1. Second row x21 plus x22 plus x23 plus x24 plus x25 equal to 1. x31 plus x32 plus x33 plus x34 plus x35 equal to 1. x51 plus x52 plus x53 plus x54 plus x55 again equal to 1. This completes the constraints of the rows, and similarly we have to complete the constraints of the column. There are 5 columns. x11 plus x12 plus x13 plus x14 plus x15 equal to 1. This is the first column. Second column x21 plus x22 plus x23 plus x24 plus x25 equal to 1. Third column x31 plus x32 plus x33 plus x34 plus x35 equal to 1. The last column x51 plus x52 plus x53 plus x54 plus x55 equal to 1. This now gives us the formulation of the problem, and our problem is assignment problem. We have to assign each job to each student. Now, same thing we have to enter into lingo, but keeping in mind that multiplication sign is asterisk, and at the end of the equation we have to write semicolon. Let us see what we have done. In this spreadsheet which has been taken from lingo, all these equations are entered now. viewers can see that whatever I said, the multiplication sign is replaced by asterisk, and at the end of each equation semicolon is added. There are 5 constraints regarding the rows, there are 5 constraints regarding the columns, and there is one objective function which is a minimization case. If it is a maximization case, we will write instead of min min, we will write max max. And after writing this program in the spreadsheet, we have to see that there is no mistake, and then we have to hit the bull's eye, means we have to hit the target. The moment we hit the target, if there is no mistake, there is no error, we must get the solution. But if there is any error, this program will tell us where exactly the error lies, and then we have to rectify. The software studies all the equations one by one and finds that if there is an error, this software will pinpoint you where the error is, and then finally you have to rectify the error and try it again. Now, moment we hit the target, we will get the results like this, and these results again we will read like this. On the top, global optimal solution is given, and it is written global optimal solution found. It means there was no error in the equations, there was no error in the problem, no ambiguity, final one correct solution is there, and it has been found by the software. Objective value, next row objective value is given, the value is 21. 21 is the number of hours which are required to complete this job by the members of the committee, and total solver iterations are 9. In 9 iterations, the software was able to give us a solution. Now, we will see the solution. All other areas, all other variables, we want that 0 value should be there, only where we have assignment 1 value should be entered. Now, looking at this table and the columns, we find that x12 has value 1. So, x12 has been assigned a job, and next one is x24, and again we have 1, again x24 has been assigned a job. Then we come to x35, this shows that x35 has also been assigned a job, and next is x53, that is also assigned a job. Even x41 is also assigned a job. So, why it has been assigned? Because 1 is there, and if we add all the timings, then these timings will be 21. So, this is our initial table, and now we have found the solution, and according to the variables, we have selected the variables whether with respect to first student, second student, third, fourth and fifth, and the names are written here, names of the students who are the members of the committee: Arati, Manjula, Shama, Saiba and Kirti. Now, we will assign the jobs now from the software output. This was the software output, and from here we will pick up the answers and we will go to our first table and assign the jobs. So, Arti has been assigned preparing brochures, and she will take only 3 hours to complete this job. Next, Manjula has been assigned purchasing prizes, and she will take only 2 hours to complete this job. Shama has been assigned preparing of certificates, and she will take 4 hours to complete the job. Saiba is assigned sending invitations, and she will take 3 hours to complete the job. And the last, Kirti has been assigned inviting judges, and she will take 9 hours. Now, if we add all these timings, the total is 21. It means in 21 hours, we shall be able to complete all these 5 jobs. Now, there is another software we have learnt this lingo with two examples. There are other problems also which can be solved using lingo. There is another software, Tora. Now, how to use Tora, I am going to explain. The moment you open Tora, you will get a screen like this, and where it is Tora is written, and for finding a solution to a problem, there is a button, click here, you click at that point, and then you will get a spreadsheet, and I will show you the spreadsheet, what sort of spreadsheet you will get. Let me show you. This is a spreadsheet and the window is given here. Window has different options like linear equations, linear programming, transportation model, integer programming, network models, project planning, queuing analysis, and zero-sum games. These are the options written here. It means using this software, we can have problems on all of these topics. We have to select the topic where exactly we have a problem. So, here we are going to discuss a transportation model. So, I have clicked on transportation model. The moment we click on transportation model, we will get a screen like this. Here the screen shows how many decimal places we want the answer. So, we can select the decimal places and finally we will click, there is a button which is written go to input screen. So, we will click that button and we will go to the input screen. Of course, there are two more buttons written here. One is main menu, other is exit Tora. Exit Tora means we will exit from Tora. Main menu means we will again go to the main menu, where again we can put another choice. If we do not want transportation model which has been clicked, we can go to some other model. To go to the main menu, we will have to press main menu button. We will have to click that button. Now, we want to solve the transportation model problem. We will click on the go to input screen. The moment we click here, we will get a screen like this. On the top, information is required. First, the title, problem title. Here one can mention just name of the problem. You can write ABC, XYZ, PQR, or just transportation problem 1. And then and after entering, we are to enter and we are not to press any other button. Just enter, then the cursor will move to the second row. Here we have to specify the number of sources, and depending upon the nature of the problem, we will enter the number of sources. After entering number of sources, we have to press enter button. Then we will go to the third, number of destinations, and here we will specify the number of destinations. Okay. Next screen I am showing you what I have done here. Title of the problem I have written PQR, sources 3 and destinations also 3. Then there is a table. First 3 information after entering, this table will open. Here D1, D2, D3, because I have mentioned 3 destinations, 3 destinations in the form of D1, D2, D3 are mentioned. And similarly sources, I have mentioned 3 sources S1, S2, S3. So, S1, S2, S3, 3 are mentioned here. Now, I can name the destinations as per their names, and I can name the sources as per the names of the sources. Then I am to enter the transportation costs in the cells which are mentioned 0, 0 values. Depending upon my problem, I will mention the transportation cost. let us see what is the next step. Here, if you see the filled up table, destination, I have written the names. First one is Amritsar, second is Mumbai, third is Madras. Sources are Delhi, Patna, Chandigarh. And again transportation costs are also mentioned as shown in the table. And then capacities and the demands are also written here. Capacities are the demand points, both are given here. D1 demand is 100 units, D2 demand is 200 and D3 demand is 400. Similarly, Delhi source gives a unit 150 in number, Patna 350 in number and Chandigarh 200 in number. And this is a balanced problem. Total of demand and total of supply is matching. Now, here at the bottom now, after entering this information in the table, we have to see what next step is to be followed. There are three buttons. First is solve menu, the middle one is main menu and third one is exit Torah. Of course, we do not require to go to the main menu because we want a solution to this problem, and even we do not want to exit Torah because we want the solution to this problem. We will click at solve problem. The moment we click at solve problem, result will be this information which the software wants from us. There is a small window which will appear. Do you wish to save data? Yes, no or cancel. If you want to save, we will have to specify the name of the file where it is to be saved. If we click no option, then nothing will be saved, only the solution will be received. Cancel, this window will get cancelled. Now, here I do not want to save it, I will just click on solve menu, okay? And the moment I click, the results will be like this. This window will appear and solve problem, because I want a solution to the problem, and there are two options available. Final solution means final iteration or all the iterations. This software can give you all the iterations and even only final solution. The moment I click at iterations where the arrow is given, I will get a window like this. There are three options available: northwest corner starting solution, least cost starting solution, and the third one is Vogel's starting solution. As in our manual method, three methods are given to us to get initial feasible solution. We can make use of any of these three methods and then can proceed. And again here we have to select one of these three methods and the software will proceed further. And let us click on northwest corner starting solution. The moment we click here, we will get a table like this. This gives the first iteration, northwest corner method. The row 150, next row 150, 200, last is 200. If we check the rim conditions are fulfilled. 100 plus 50 is 150, which is the source capacity of source Delhi. 150 for plus 200 is 350, again which is the source capacity of Patna. Last one 200, which is the source capacity of Chandigarh. Similarly, the demand for Amritsar 100, which has been written. 50 plus 150 is the total is 200, which is the demand for Mumbai. 200 plus 200 is 400, which is the demand for Madras. This now fulfills our rim conditions. This is the first iteration. And now at the top of this particular table, there are three buttons mentioned. One is next iteration. If we want to see the next iteration, we will press next iteration. So, we will get the next iteration. If we click on the all iterations, then it will show all other iterations till our problem is solved. And then we can write this to the printer also by clicking at write to printer. And this is the way we operate the software. Now click. After clicking, just one thing is to be noted, the value of the objective function here is written on the first row of this table. Objective value is equal to 5450, and this is the final solution also. This is the final solution also, and this has been completed in 3 iterations, and this will show you how many iterations have been used. And this was transportation model using Tora software. Earlier we studied Lingo. Of course, this particular transportation problem can be solved in Lingo also, but I just wanted to show you how our manual methods are translated into a software, and identical procedure is followed in software also. Tora follows exactly the same procedure what we use in manual methods. Now we have one more question which has been solved using Tora. Let us try zero sum game. In the game theory, zero sum game. Let us click on the zero sum games, and the moment we click, we will get this table. Here again, as done in the transportation model, we will have to specify the name of the problem and what are the strategies available to one player, how many number of strategies are available to the second player. Here we have considered 2 strategies each to each player. The moment we enter 2 in A and 2 in B, we get a table as shown in the slide. A has 2 strategies A1 and A2, and B has 2 strategies B1 and B2, and their gains are again A1 12 and 10 and A2 8 and 9. These are gains of the player A shown in this table as we enter manually in the tables in game theory. Now again there are 3 buttons available: solve menu, main menu and exit Tora. Of course, we will press solve menu. The moment we press this solve menu, we will get this window. Again, solving problem, there are 2 options available: graphical method and LP based method, means linear programming based method. Let us try with graphical method. We will click on graphical method. The moment we click, we get like this graph, and this graph is obviously clear that what exactly is the outcome of this result. Now, at the left hand side, B1 and strategy 8, outcome B2 outcome is 9, and then optimal solution value of the game is 10, and strategy A1 1, strategy A2 0. This shows that this has a saddle point, this game has a saddle point. A1 playing now A playing A1 strategy and B playing B2 strategy all the time, because it is a saddle point. And now we will have another problem where we do not have a saddle point. Again there is another problem. Again 2 players are there with 2 strategies each. Now we have changed the gain from these strategies, and these gains are now entered here in this table as we did in the previous question. After entering these gains, actually these gains are of player A and losses of the player B, because it is zero sum. Whatever player A gains, the same amount player B loses. We will press it on the solve menu to get the answer to this question. The moment we press, we will get graphical solution as shown here. Now, look at the graphical solution. We see that graphical solution, if we see the optimal solution, value of game is 4. Where these two lines cross, against this if we read it is 4, it means the value of the game is 4, and where this vertical line at the point of intersection intersects the x-axis, that will give us a percentage of the times player A will play one strategy. And now looking at the results, player A's strategies, this is strategy A1 is 0.4, strategy A2 is 0.6. So, this particular question is of a mixed strategy. The earlier question was of pure strategy. This shows that 40% of the time player A will play A1 strategy, 60% of the time player A will play A2 strategy. Now, we see the results of player B. The results of player B shows that B will play B1 strategy 50% of the time and B2 strategy also 50% of the time, as this is a case of mixed strategy. And this is the way how we solve problem of game theory using Torah. And similarly, we can make use of LP procedure also, means linear programming procedure also. The results will be same, of course. A1 strategy percentage is 40%, A2 strategy percentage is 60%. This is with respect to player A. And similarly, B1 strategy is 50% and B2 strategy is also 50% with respect to player B. So, this way we have shown two problems on game theory. One was of pure strategy, other was of mixed strategy using Torah, and prior to this we studied transportation model in Torah. We started with Lingo. In Lingo, on the spreadsheet we formulate the problems and then hitting the target we get the solution. I hope I am able to describe Lingo and Torah, and now the viewers will be conversant with these two type of software, and with simple examples I am able to explain the procedures which are to be followed in each software. There is no limit to the use of these software. These software can be used to a number of problems on operations research, and the solutions can be sought. I started with very simple problems so that the viewers can understand the procedure. Viewers can make use of these software in their big problems with bigger statements, with more number of variables, and then find the solution. Because in practice we do not have small problems, we have big problems with big constraints and where the number of variables are also very large, and we can make use of software to get the solution. I hope I am able to describe these two software to the viewers. Thank you.
Thank you, sir. Thank you so very much. As we already said that since very long we are carrying series on operation research. Since 1 year almost we have conducted numerous lectures on operation research. So dear friends, if you have any feedback or you have any queries related to operation research, or you would like to ask any question from Dr. Subhash Kakkad, I would like to tell you all that your queries would be solved in later lectures when Subhash Kakkad would be again with us. For that,
even the viewers can ask us if they want to get repeat of any lecture. We can repeat the same with the same topic which the viewers want again.
Definitely. So, for all these queries, for all your feedback, you can mail us at info.cec@ nic.in. I would like to tell you all, info.cec@nic.in is the ID where you can post your mails, you can post your feedback, you can ask questions, and of course we would love to solve your queries, your questions in the next session when Dr. Kakkar would come again. And I would like to tell you all that you can access this particular lecture on operation research using computers, that is with the help of the computers. We try to explain how operation research problems could be solved. You can definitely ask questions, as well as you can access this particular lecture with the help of YouTube. As we always say that we upload our lectures daily on the YouTube for you to understand the topics very easily again and again. Thank you, sir.
Viewers can also ask us on other topics which have not been covered so far. We will be willing to do that. A special lecture can be held on that particular topic where the viewers want the help.
Definitely. And if you like to have lectures on certain topics, of course you can mail us. Thank you, sir. Thank you so very much.
Thank you.